Okay, so we are going to go over the bonding unit exam that we just took so that everybody can understand where their mistakes were. Let's start with question 1. Which formula represents a molecule with the most polar bond? So in order to answer this question, we need to use Table S, and we're going to look at the electronegativity difference. So we need to look up the electronegativity values for each of the elements, and we need to subtract them. And the one that's going to have the largest difference is going to be HCl. In the next question, which phrase describes a molecule of CH4? So we have to look at CH4. So remember, we put our C in the middle, and we have 4 H's coming out from it. This is a symmetrical molecule, so right away we can get rid of choices 1 and 3, which say asymmetrical. We have a choice between polar with a symmetrical distribution of charge or nonpolar with a symmetrical distribution of charge. Remember, molecules are nonpolar in 2 respects, either Brinkelhoff, where they are symmetrical with an electronegativity difference of 0, or they're symmetrical in this case and the charge is equally distributed, which makes it a nonpolar molecule. So choice 4. Moving to question 3. Which element has atoms with the strongest attraction for electrons in a chemical bond? Attraction for electrons in a chemical bond. We went through vocabulary, guys. This is the definition of electronegativity. So this question might as well have been asking you which one has the highest electronegativity. And I remember saying that fluorine is the bully of the periodic table, has the highest electronegativity, 4.0. Question 4. When lithium reacts with bromine, so right away, before I'm even thinking about looking at the question, I know that lithium is a metal, and I know that bromine is a nonmetal. Right away, I know I have an ionic bond. And in an ionic bond, there is a transfer of electrons. Remember, metals like to lose electrons in order to have 8 in their outermost shell, and nonmetals like to gain. Well, if we look at lithium, we can see it has 1 valence electron. So it's going to lose an electron, and just like losing weight, when we lose weight, we become positive. Okay, let's come over here now. Which formula represents 1 ionic compound and 1 molecular compound? Remember that I told you that another word for molecular is covalent, and you had to know that. Ionic is going to be a metal and a nonmetal. I see that right here in number 3. And then N and O are both nonmetals, so that was my answer. I'm just looking at the responses. 1 is all covalent and 2 is all covalent. Some of you might have picked choice 4, BaSO4 and NaOH. However, these are predominantly ionic, but they are ionic and covalent because anything that contains a polyatomic ion has both ionic and covalent bonds. And I'll explain that in part 2. Given the formula for hydrazine, how many pairs of electrons are shared between the nitrogen atoms? They're talking about that right there. 1 line equals 2 electrons, so that is 1 pair. If I had a double bond, then it would be 2 pair, a triple bond, 3 pair. What is the number of pairs of electrons that are shared between the nitrogen atoms in a molecule of N2? We talked about this in class. We actually went through it in the practice. We did it with oxygen first. And with oxygen, O2, we know that oxygen has 6 valence electrons. It needs to gain 2. So if it's only bonding to itself, it's going to do so by a triple bond. A double bond, excuse me. N2 has 5 valence electrons. Therefore, if it's bonding to itself, it needs 3. So it's going to do so by a triple bond. To break a chemical bond, what must happen with energy? Recall I said the window does not break by itself, but if I hurl my stapler at it, it will then break because the window absorbs my energy. So to break a bond, we absorb energy. Moving on to page 2, which Lewis dot diagram represents a molecule having a non-polar covalent bond? Non-polar means that there is a symmetrical charge distribution. It also means that there is a sharing of electrons. So it's definitely not 3 because that's ionic because we have the brackets in charge. And it's definitely not 2 and 4 because you can see that this has got pull in this direction. This is going to be slightly negative, slightly positive. Same here. My chlorine has got a slightly higher electronegativity than hydrogen, so this is polar, but there's my nonpolar molecule. An ionic bond can form when one or more electrons do what? Ionic, you have to know, is between a metal and a nonmetal, and there is a transfer of electrons. Electrons are not in the nucleus. They are in the valence shell, so choice 4. Which statement explains why Br2 is a liquid at STP and I2 is a solid at STP? We went through this when I went over pages, 26 to the end there. Remember, it has to do with intermolecular forces. Both of these are Brinkelhoff, so they're both going to be nonpolar. The one that is bigger, which is I2, is going to have stronger forces, which is why it is in the solid state. So I2 has stronger forces than Br2. And 12. Which molecule has a nonpolar covalent bond? Again, nonpolar, I'm looking for symmetrical in shape, equal charge distribution. My Brinkelhoff always wins out on those, unless, of course, it's something like CH4 or CCl4 or CO2, which I talked to you about. Okay, let's move over here. Given the formula representing the molecule, this molecule is what? Well, it's linear, and you've got 2 C's in the middle and 2 H's, so you've got C pulling in this way, C pulling in this way, equal and opposite. It is symmetrical and therefore nonpolar. Which element forms an ionic compound when it is with lithium? Well, lithium is metal. It's on the left side, group 1. For an ionic compound, I need a metal and a nonmetal. When in doubt, odd man out. This is a metal. This is a metal. This is a noble gas. And there's your nonmetal. What type of bond is found between atoms of solid cobalt? Cobalt is a metal. Therefore, it is metallic. Which formula represents a polar molecule? Well, I just drew CO2 for you, so you know that's nonpolar. CCl4 is just like CH4. That is also symmetrical and therefore nonpolar. H2 is Brinkelhoff. You know that's nonpolar. I told you to know that water was polar. There you go. Not to mention the fact that it looks like this. So my dipole moment is toward oxygen in this direction. Alrighty, moving on to 17. The liquids hexane and water are placed in a test tube. The test tube is stoppered, shaken, and placed in a test tube rack. The liquids separate into two distinct layers because hexane and water have what? Well, we talked about this, and I went through a whole discussion about why oil doesn't mix with vinegar and about why fat doesn't come off a plate when we run water over it. And I recall saying that that's because water is polar and that other substance has got to be nonpolar. So they have two distinct layers because they have different molecular polarities. Water is polar and hexane is nonpolar. You don't have to know what the other substance is. If I tell you that something dissolves in water, it's because they have similar polarities. Like we know vinegar dissolves in water. Oil does not. That's because oil's nonpolar. So you don't have to know what the other substance is. I could say naphthalene will not dissolve in water. Naphthalene, by the way, are mothballs. Why don't they dissolve in water? Because they don't have the same polarity as water. Which formula represents a molecular compound? Remember, molecular means covalent. That in turn means nonmetals only. You could have figured this out by process of elimination. This is a metal and a nonmetal, metal and a nonmetal, metal and a nonmetal, two nonmetals. All right, moving on to page 3. Why is a molecule of CO2 nonpolar, even though the bonds between the carbon atom and the oxygen atoms are polar? I drew it before. It's because it is symmetrical in shape, equal and opposite pole. O is pulling this way, O is pulling this way. Next question. Which type of substance can conduct electricity in the liquid phase but not the solid phase? We went through this. I did a demo. Metals conduct. Why? They have mobile electrons. Ionic compounds, however, only conduct when they are melted or they are mixed with water. And we specifically said that covalent compounds very rarely conduct. We also saw that in the lab that we did because I gave you the conductivity values. The compound XCl is classified as ionic. If X represents what? Well, if this is XCl, you know that Cl is a nonmetal. If it has to be ionic, then X has to be a metal. There's only one metal here, rubidium. Okay, 22. The chemical bond between which two atoms is most polar? Again, most polar was like the first question. You need to go to table S. You need to look up the electronegativity values. And subtract them. And the one with the biggest difference is the one that's going to be the most polar. And that is going to be choice 4, SiO. The bonds in BaO are best described as, well, I'm going to look at my periodic table and I see that Ba is a metal And I see that O is a nonmetal. That means that it is covalent. These get knocked out. And in covalent compounds, electrons are shared. Okay. A solid substance is an excellent conductor of electricity. It's solid. Therefore, the only thing that conducts in the solid state has got to be metallic. And that's because it's got mobile electrons. Which term indicates how strongly an atom attracts the electrons in a chemical bond? Attraction for electrons. Electronegativity. Which diagram below shows the correct Lewis dot diagram for a molecule of phosphorus trichloride? Remember, phosphorus has 5 valence electrons. 5 valence electrons. So the first thing we would do is draw our P with 5 valence electrons around it. And then you've got 3 Cl's, each with 7. So you got Cl, 3 times 7. That's a total of 21. So each Cl is going to come in on each side. So when you're all said and done, okay, and you get those Cl's in there, you better have 26 electrons. And that is going to be choice 3. What is the correct Lewis dot structure for a compound magnesium fluoride? Remember, the first thing that you need to do is you need to figure out the compound. Mg has a +2 charge. Fluorine has a -1 charge. We drop and cross. We get MgF2. So we know that magnesium, electron configuration 282, wants to give up 2 electrons. We know fluorine, electron configuration 27, wants to gain 1. That's why we need 2 fluorines. We also know that this is ionic, so we need brackets and charge. So our Mg is in the middle. It gives 1 to each fluorine. Brackets go around who's gaining. Each one of the fluorines gets a -1 charge, and the magnesium gets the +2 charge. Okay, a chemist performs the same tests on 2 homogeneous white crystalline solids, A and B. The results are shown below. So you see that this one has an extremely high melting point, and it is a good conductor. Right there, I should be screaming, oh, it conducts in aqueous solution, so that means it's with water. So this is screaming ionic to me. This one is a non-conductor, and it's got a low melting point, kind of like sugar. This one is screaming covalent. So solid A contains ionic bonds, and B contains covalent bonds. So let's move on to part 2 here. And in this question, what I noticed on all part 2 questions is that you guys freaked out and didn't answer the question in some cases. You didn't look at what the question was asking you. It said compare the intermolecular forces. I can't tell you how many responses I read and nobody mentioned the word intermolecular forces. We went over this. We said that intermolecular forces are directly related to melting and boiling point. The higher the melting and boiling point, the stronger the force. All we had to say here was that ethanol has stronger forces. Than ethane. That's all I needed. Okay? It would have been great if you said because it had a higher boiling point, but I just really needed that. Identify the type of bonding in solid potassium. I told you to either put metallic, ionic, or covalent. Solid potassium. Potassium is a metal. Just like gold. Gold atoms. Mobile electrons. So this was metallic. In order to be ionic, you need a metal and a nonmetal. When I just say potassium, you don't have two things present. You only have one. Okay, and the last question. Actually, I think there's another one after this. Identify the type of chemical bond in a molecule of the reactant. I went around, anybody that asked me what the reactant was, I told them. Talking about this guy right here. That's the only reactant. What kind of bond? You could have told me a couple of things. You could have said nonpolar. You could have said covalent. You could have put them together and said nonpolar covalent. And you could have even told me double bond, because oxygen, when bonded to itself, has a double bond. Any of those four responses got you the point. Okay, these last two questions just happened to work that way. They wanted to know what two types of bonds are in the compound sodium stearate. So here's our sodium stearate. And basically, whenever it asks for two types of bonds, it's always ionic and covalent. You've got the Na in there, so you know that you've got some metal, and then this whole side is nonmetals. Over here, this is one that you're even used to more seeing. We did a whole page of these. It was the second or third page of the packet where you had to tell me if something was ionic, covalent, or both. Do you remember that? And we said that anything that contained polyatomic ions is going to be both. And I'll explain it again. Yes, guys, the NH4, that's an ion. This is covalent. The NO3 minus is a polyatomic ion. This is covalent. However, when they form a bond, one electron is transferred to the nitrate. This transfer of the electron makes it ionic as well. So anytime it asks for both types of bonds, two types of bonds, it's always ionic and covalent. Okay, that's it.